Section 3.7 is really a lead-in to the next chapter in the textbook, which is going to be all about ionic and covalent compounds. Ionic compounds are made up of ions. The ions in an ionic compound extend in all directions to make a relatively large three-dimensional array of ions. Molecular compounds, which are also called covalent compounds or covalent molecules, are generally made up of smaller numbers of atoms in very specific amounts with very specific attachments. Ionic compounds are made up of cations and anions. The positive charge of the cations attracts the negative charge of the anions. This electrostatic attraction based on their charges holds ionic compounds together. The ions in ionic compounds can be monatomic, having one type of atom, or polyatomic, with a single ion containing multiple atoms. Metals tend to become cations by losing electrons. We finally understand why now that we have talked about periodic trends. The energy of losing electrons would be ionization energy, and we know that metals, since they are in the lower left portion of the periodic table, have low ionization energies. That means that it is easy for metals to lose electrons. Metals lose electrons in order to have the same electron configuration as the nearest noble gas. For example, neutral potassium has 2 electrons in its first energy level, 8 electrons in its second energy level, that is 2s2, 2p6, 8 electrons in its third energy level, and 1 electron in its fourth energy level. When it becomes an ion, it loses that one valence electron, so it can have this same exact electron configuration as argon, having a full outer shell. Metals in groups 1A, 2A, and 3A tend to lose all of their valence electrons in order to have a noble gas configuration. Remember, their number of valence electrons is the same as their group number. So for metals in groups 1A through 3A, their group number will also be the charge that they take on when they become an ion. For example, calcium is in group 2A, so it loses its 2 valence electrons and ends up with a +2 charge overall. Nonmetals tend to become anions by gaining electrons. Since nonmetals are in the upper right part of the periodic table, they have high electron affinities, meaning they like to gain electrons. They gain electrons in order to have the same electron configuration as the nearest noble gas. For example, neutral sulfur has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p4. There are still 2 open spots available in the 3p subshell. It gains 2 electrons to fill those spots and have a full outer shell with the same electron configuration as argon, its nearest noble gas. For nonmetal ions, you can count how many spaces you need to go to the right on the periodic table to get to the nearest noble gas, and that will be the amount of negative charge that will be on the ion. You could also take the group number and subtract 8 to get the charge. For example, nitrogen is in 5A. 5 minus 8 means nitrogen will have a -3 charge when it becomes the nitride ion. You can see the charges for some ions on this periodic table. For the A's, that is the main group elements, counting from the left, you have +1, +2, and +3. Counting from the right, you have 0, -1, -2, -3, and -4. For the B's, that is the transition metals, notice that most have a variety of different charges. It will not be possible to determine the charge on a transition metal ion based on where it is in the periodic table.